Hey, this is Andrew here. Let me just minimize this. Alright, here's for another video. It's going to be real quick. I'm doing a new project. I thought it would be a good idea to show the design process and the thought process that I have behind making a robot, like an entire robot. So I'm going to have a short video series about the steps I'd take to recreate a Stronghold robot. In this case, I will be making a really simple off-season robot for Stronghold. If you haven't seen that game yet, it's the 2016 game. If you haven't played it, don't know what it is, I'd go watch the unveil video for the game. I'd read the rules, because these next few videos aren't going to make too much sense. Also, they'll make a little sense, but it's good to have the background to understand what I'm trying to say. So this will be the first video. I'm just going to go over my really simple strategic design, strategic analysis of the game. I threw together before putting the video on. What it does is it lists what I want my robot to do. It lists some thoughts and some limitations that I put for myself. I'm not going to go too much into detail on why I chose them. That'll be a separate video of strategic analysis and trying to figure out how to correctly play a game, or how to best play the game for your team. That's a better way of saying it. For now, this is all I really put together. I separated my functionalities into 3 different types, really just 2 different important types. And then I added my limitations. This is a really simple way you can flesh out for off-season projects. Just get some basic pointers out of the way and just go ham on the robot real quick. I'm just going to go over right now my necessary functionality. I want my robot to go under the low bar. I want it to cross the cheval de frise. I want it to cross over the moat, go over the ramparts, cross over the rock wall, go over the rough terrain. I want it to maneuver quickly, not quickly. Okay. Throughout the field, I want to quickly and actively intake a boulder. The reason I say quickly and actively is, for those who don't know, active control just means you're always, what's the way of saying this? You always have control over what's going on. So it's usually bad practice to have your game piece influenced solely by inertia or gravity. We did something like that on 1323 this year, where the ball came in through the intake, and then it sort of just rolled through our robot. And it worked great in practice, but trying to get that ball to center up was pretty difficult. So that was our mistake. So one thing I want for this robot is I want active control. I want to always be in control of the boulder as soon as it enters the robot. I want to do that, of course, quickly. I want to, like I said, control the boulder until scoring. I want it to be in my robot. And, of course, I want to score the boulder in the low goal. This isn't going to be a high-shooting robot. My preferred functionality, so it's not necessary. If I can't do it, it's not going to kill me. But what I want to do, just for fun, I want to have a double-sided intake. Essentially, I don't want to have to turn around if I want to intake a ball, or if I need to score a ball, I don't want to have to turn around. I'm thinking an open frame, and that's just opening up the frame to intake the boulder. Not entirely sure all the details behind that yet. I haven't really fleshed it out. I have a slight idea of what this robot's going to look like, but just to make this a realistic kind of video series, I want to walk into this not exactly having a complete plan. So be a little bit more representative of the thought process of creating a new robot, and I'll try to externalize my monologue or what I'm thinking, because most of this just goes on in your head when you're making a robot. But hopefully I can communicate my thoughts effectively. External limitations, I always like to design around my own limitations outside of what the game gives me. This one's a little bit within what the game gives me. You do have a height limit, and if you want to go under the low bar, you have to be under 16 inches. However, because the low bar's raised up on a ramp, the effective height of your robot is going to be around 14 inches. I could show the sketches and geometry around that. I won't. Just know of course, you're easier to go under if you're a little bit shorter. So I'm going to say 14. It's always fun to try and design smaller, so I'm not really going to make this robot too big. I didn't list that as an external limitation, but this robot doesn't need to be large at all, so I may not use full size. I may just make it a square. I may, though. I mean, the idea I have in mind are, here I am already having ideas that I should not be doing that yet. Haven't even started designing. But yeah, that's pretty good there. And ideal functionality, I mean, my ideal robot would be a swerve with elevator connected to a 4-bar and a turret at the end, and of course a vertical spinning shooter wheel. But that wouldn't be nice for this video. Like, wouldn't be easy to follow, and I'd probably take a lot longer. So I'm not gonna do that. Maybe that'll come later on. All right. So that's just the list right now. In the next video, I'll start going over some geometry sketches just to get my dimensions, my general shape fleshed out, maybe try out some ideas in terms of design. Alright, that should be it for this. I will see you in the next video.